So if I'm here, command/works in visual mode. And then if I'm in insert mode, command/ still works. Sweet. Okay. I really like taking the time to improve your usage of your tools, even though that was, a distraction from what we were trying to do today. Over time, these things build up and they become second nature, and you can actually become really productive in your tools. But it takes like pausing for a second and solving a problem or researching a plugin or what is that keystroke or whatever. And you just sort of try to commit that one thing to memory. So if you do that every day, awesome. Okay. Day 6, lanternfish. The seafloor is getting steeper. Maybe the slay keys got carried this way. A massive school of glowing lanternfish swims past. They must spawn quickly to reach such large numbers. Maybe exponentially quickly? You should model their growth rate to be sure. Although you know nothing about the specific species of lanternfish, you make some guesses about their attributes. Surely each lanternfish creates a new lanternfish once every 7 days. Okay. However, this process isn't necessarily synchronized between lanternfish. One might have 2 days left until it creates another lanternfish, while another might have 4. So you can model each fish as a single number that represents the number of days until it creates a new lanternfish. So every time it creates one, it resets at 7, but they all start in different places. Furthermore, you reason, a new lanternfish would surely need slightly longer before it's capable of producing more lanternfish. 2 more days for its first cycle. Okay, so suppose you have a lanternfish with an internal timer value of 3. After 1 day, it goes to 2. After another day, it's 1. After another day, it's 0. After another day, the internal timer would reset to 6, and it would create a new lanternfish with an internal timer of 8. After another day, the first lanternfish would have an internal timer of 5. Second lanternfish would have an internal timer of 7. Okay. A lanternfish that creates a new fish resets its timer to 6, not 7, because 0 is included as a valid timer value. The new lanternfish starts with an internal timer of 8 and does not start counting down until the next day. Realizing what you're trying to do, the submarine automatically produces a list of the ages of several hundred nearby lanternfish. This is your puzzle input. For example, suppose you're giving the following list. This means that the first fish has an internal timer of 3, second has 4, and so on until the fifth fish, which has an internal timer of 2. Simulating these fish over several days would proceed as follows. So we have initial state, and after 1 day we have that, and then we just keep appending fish onto the end. Okay. Each day, a 0 becomes a 6 and adds a new 8 to the end of the list, while each other number decreases by 1 if it was present at the start of the day. In this example, after 18 days, there are a total of 26 fish. After 80 days, there would be a total of 5,934. Find a way to simulate the lanternfish. How many lanternfish would there be after 80 days? Okay. Exponential growth kind of scares me, but let's see. So let's go to day 6. Let me minimize that. Okay. Which day is this? This is day 6. Advent of Vim config, seriously. I'm also somewhat out of the loop. I'm trying to avoid watching anyone else solve these problems, so I'm not like, my solutions aren't just sort of inspired by somebody else's, because part of the point of this is to practice programming, right? And the reason why I'm not, I don't think it's wrong if you are doing Advent of Code and you're getting inspiration, but I don't want to, because I want to produce sort of unique, authentic content for other people. So that's kind of where my head is. Okay, so what do I want to do? So we start basically every single one as reading a file. So we're going to say read file, and this will be day6.test. And then let's go add that. So in my resources, we'll say day6.test. We will paste that in. Then we will go back over to day 6. And at this point, we could just deal with raw numbers, but I kind of like, modeling the domain. So here, maybe we have a private var for age, which is an int. And we can create a new fish with a given age. And then at some point, we have sort of a, let's see, what did they call it? Age or life? What did they call it? Internal timer. Because I kind of want this to have a function. This would be, if this is a struct, then this is a mutating function. That it's some sort of, it's like the passage of time. I don't know, grow. Maybe we just say process day or something. I don't really know. It's a bad name, bad method name. Evolve, but that's a little bit too much. I don't have a good name for this. Process day. Okay, so at this point we could say age minus equals 1 or something. And the idea here is I would have the fish be input.lines, and lines is a function I wrote last time. Or a couple times ago, just a helper function. And for each one of those, I want to, actually, no, is our input just one big line? I think it is. Yeah, it's just one huge comma separated line. Okay. So we don't need to do that. We just split the input on the separator comma and compact map that to int.init, but I can't do that. Actually, I did make that work as well. I'll quickly show. util.swift has some of these things, like taking a string, splitting it into lines, stripping white space, and also being able to initialize an int with a substring, which is what I'm using in this case. And that allows me to use compact map with just the function reference. And the reason why this is necessary is because split gives me an array of substrings, not an array of strings. And so I want to be able to easily compact map that. So that gives me ints. And then I just want to map that to lanternfish.init. Okay, so now I've got a bunch of fish. And I'm going to have some sort of simulator. I'm going to make this a class because this is going to be... we'll call this the lanternfish simulator. And this will keep track of all the lanternfish. Now, when I mutate one of these things, it will mutate a copy. So I'm not sure if I want to do this in this sort of functional immutable style. It certainly would be easier if these are all classes. In fact, I think I'm just going to do that because I've done structs in the previous ones, and you end up having to do things like replace the element at the index 5 with the new copy of this data. Whereas if these things are classes, I can just mutate them directly. So I think I'm just going to do that. And I guess it's important also to note that lanternfish never die. So, yeah, I think I want to call this tick, honestly. Like tick is the kind of like the passage of time. Okay, so I've got some fish. We will initialize with some fish, lantern fish. This will become private. And we'll say self.fish equals fish. Int.init. Yeah. Okay. So at this point, we would like to print out, I don't know, run simulation. And we'll say how many days do we want to run. And we will say we want to print out the fish after day so many days. So initial state, we'll just print it out like that. So print out initial state. And I need a function to print out the fish ages. So we'll say private var fish ages string or something like that. So I can say fish dot map to their age. I want that to be private set, I think. So I can say age dot joined separator comma, is it comma space? No, just comma. And that'll be my fish ages string. Let's see, is it joined or join? Map string.init, then join. Is that what I want? Yeah. Okay. Okay, so then I can say for day in days, 0, 0 up to and including days. So if we go for 1 day, then I need to start at 0 and go up to that number. Or do I want to call this 1 up to that number? Yeah, not 0. Yeah, so we'll say run simulation for like 1 day, and then we'll say print after day, and then we'll print out the fish ages string as well. So then this would be, fish dot for each, and then we can pass in tick. Let's see, does it not like that? For each fish in. Okay. What about an NS array that holds structs? I try to avoid foundation, or not foundation, but I try to avoid the Objective-C stuff because it kind of keeps your foot in the Objective-C way of doing things, and you can potentially bring yourself to a point where you can't really do Swift without Objective-C. And so I generally try to avoid it if I can help it. But yeah, if I have a Swift array of structs and the array is mutable, then I can replace items in that array, but I can't mutate items directly in that array because I basically create a copy. So if I say fish 0.age equals 1 or whatever, assuming that was mutable, then this, I believe this would work, but then you might want to do more than just this work. Yeah, I don't know. I don't necessarily think there's anything wrong with having a class here, but I do think that as you go to like multi-core, concurrency and things like that, having things done in a little bit more functional style, the more immutable style, where instead of the fish aging like this, you could have like, say, a fish that's a struct and it has an age, and then it also has a function called tick, which returns to you a new optional fish. It probably, yeah. So what this could do is return to you a new fish and a new spawned fish, right? And so this would be purely functional, purely immutable. So you'd replace this fish with a new one that has the age you want plus an optional other fish. So in that case, or you could say that maybe it spawns multiple fish. And so when you tick, you always return an array of yourself, but optionally your children that you just spawned. If tick is eventually going to mutate the fish array while you're iterating it, you might be headed for trouble. Yeah, might be. Yeah, I don't want to solve all these problems before you like run into them, but yeah, you're right. I'm iterating over an array, and then this is probably going to add to that array. But I could also just say, give me the new fish here, and then add to them self.fish equals, well, I could say fish.append contents of new fish. So they're always at the end, something like that. Because these fish don't process the results in this day, right? You only tick the current set of fish and then you append the new ones on to the end. So, that's lantern fish. Let me get rid of the rest of that. Yeah, okay. Okay, so now that I have my fish, I'll get my simulator. That'll be a lantern fish simulator, and we'll create that with the fish that we just created. And then we will say sim.run run simulation. And we'll just run it for one day, and that should print out the results that we want. So let's build and let's run. So our initial state was 3431, 34312. So I already have an off by one error. That's amazing. What did I do wrong here for each fish? We do have a flat map in there. Let me just check my day 6 input and make sure I got everything in there. 34312. Okay, so in my input, we compact map that here. Is there white space at the end of one of these? No. Let's just quickly print that out. Goodness. Okay, let's make custom string convertible, description, string. We'll say fish. Like that. Okay. Fish 3431. Okay, so we are missing number 2. So we split on that. So this should be, let's just let x equals this so we can see what it is. Print x. Yeah, so we've got a new line character at the end. So let's do map trimming characters in white spaces and new lines. White spaces and new lines. So that should be lowercase. Okay. Okay, so now we have our input, and after day 1, we've got 23201. So let's take a look at here. 23201. Okay, so that's good. And then when this one becomes 0, we need to spawn a new fish. So we can say fish.tick, and then if fish.age is 0, no, we only want to do that. I kind of want the fish behavior to be internal. So this one might spawn a new lanternfish. Okay, so we'll do age. We'll say if age is 0, then we're ready to spawn. And so our age is going to get reset to 6. And then we are going to return a new lanternfish whose age is 8. And I kind of want constants for that. So this will be private let parent age is 7. Well, let's call it 6. So this would be parent age. And this would be parent age plus 2. Now, let me just wait before I introduce constants, because I think this may change in the next puzzle input. Okay. Yeah, so if our age is already 0, then we spawn. So we reset our age and reset age. And then this one will return nil. Okay. And we need to then grab new fish. So we'll say if let new fish equals fish.tick, then we'll say new fish.append new fish. Let's call this child. Okay. So that's good. So let's add another day to it. Okay, and now we get a new one that is 8, which I think is correct. When the second generation of, say, cheesy solution is to append a comma to input before you split it. That still wouldn't work because my input had a new line. So appending a comma would append the comma after the new line. When the second generation of lantern spawns the new generation, does its age reset to 6? No, so the second generation will stay at 8 and it will just tick down. But when it gets, so that's basically just for newborns. So they basically don't start their parental timer until they're at 6. And from that point, they can just keep producing. So no, you don't need to keep track of the original age. Okay, so I think that our output was correct. Let's run so I can just kind of have it here. 121608. 121608. Okay, after 3 days. So I think that our solution will work. So let's just run this after 18 days to compare with this one. And just to double check that we don't have something wrong yet. After 18 days, run. And our 606 456 0112 0112 and then 8888 at the very end. Looks like we are good. So let's run this for 80 days. And then we also need to count how many fish there are. So print total fish our sim.fish.count. Let's do private set only there. Okay. After total fish after 80 days, 5,934. I think that was correct. Yes. Okay. Does it matter where you add the new fish into the array, like right after the parent or at the end of the array? In this input, they're always appending it onto the end. And I think that sort of maps to what we were talking about earlier, that if I were to modify the array that I'm iterating over, right? I'm saying for each fish, and if I say fish.add new fish here, or child or whatever, if I were to do that, then now I'm changing what I'm iterating over. And this is usually a bug. Like for instance, let's say under the hood, this was using a for loop with index 0 to the total fish count. Then you would start iterating over this fish that would have occupied an index of a different one, and then you would not end up iterating over the whole collection. And then if they're using an iterator internally, it's just like the results are not good if you're trying to mutate the array. Some languages and some loop constructs will actually warn you that you're mutating an array while you're iterating over that same array. So this also fits in with the fact that we don't want to tick any fish that were just born. So I think that this actually works pretty well. So what we need to do now is go over to here and add day6.input. And let's go grab our puzzle input. And go back here and we will say read day6.input. And we will build, and I think the output is going to be a little nuts, so let's run it here. Okay, 343,441. So we'll paste that in there. That's the right answer. Let's continue to part 2. Suppose the lanternfish live forever and have unlimited food and space. Would they take over the entire ocean? After 256 days in the example above, there would be a total of, wow. Yeah, it's going to be fun to see what the memory looks like for this. I know these are just integers we're storing, but let me grab advent of code, the process, so we can see it, and then we'll run it again and see if we can capture the output. It looks like no, but when we run the next part, 256 days, I may not want to print it out anymore, actually. I don't think I want to print out the fish ages string. I just want to print out the count of fish. So let's call this the fish string. And if fish.count is less than 100, then we're just going to print out all of the fish. Otherwise, so let's return. Otherwise, we're just going to return the total count, because otherwise the output will be ridiculous. So fish count is fish.count. Okay. So that would be, what did I call it? Fish string. And same thing here. Okay, so after 256 days, let's run it again. I'm going to keep the activity monitor open so we can see what happens. And so we're at 40 megabytes right now. $318. Yikes, this is getting ridiculous. Half a gig. A gigabyte, and we're just storing integers. This is crazy. So think about how big is our integer size. It's, I think, 32 bits, right? But we're only ever storing a really tiny number. So we could actually use an 8-bit integer, or even less, right? A 3-bit integer. In Java, that would already be 18 gigabytes. Yeah. Okay, so you see this exponential growth is actually killing us here. So, man, okay, so this is interesting. How do I want to improve this? Certainly, I made that whole comment about structs being like not necessary here. It possibly could make this faster because there's no allocation. There's no allocation step, right? It just goes on the stack. But still, we just have the same memory footprint. Let's see. How do we want to do this? We could store all, yeah, I think what we want to do now, instead of storing every single fish, we could store all their ages and just see how many fish do we have at each age. The other thing I was thinking of is rather than using an 8, like let's say we use uint 8 here instead, just to get a sense for, we were at 2.5 gigs after 137 days. Okay, so just to get a sense for what happens if we use a smaller, 1/4 the size. I think, what else do we need to do here? This needs to be compact map. Let's do map that to uint 8. Is that gonna work? Yeah. Okay. Let's, I don't want to run here. Please don't run there. It'll block up my Vim setup. Okay, so we're gonna run this guy and kind of see. Want to be a 64-bit int. Is int by default 64-bit? Thought it was 32, but could be wrong. Assigned integer value on 32-bit platform. Oh, you're right. 64. You are correct. So yeah, so we are using way less memory now, but still, it shouldn't take a gigabyte of memory to do this. And it's going to get worse, right? Like every single day, we're adding so many fish. Hey, Beat Sampler. How are you? Okay, so I think we were at 137 days before, so we are using way less memory, but you could see that we're never going to get to 256 at this rate. So I think instead of storing every single fish, it doesn't really make sense. We've got so many and they only occupy 8 total or 9 total values, right? So it's like we really just need a different data structure that doesn't store every single fish, because we don't need to do that. So instead we could say we could say fish by age, and this will have the age as a uint 8, and I don't even need to do uint 8 anymore, because like we're not going to care. We're going to have so few of these, so we'll do that. So this does mean that this sort of class doesn't really represent what we're trying to do anymore. But let me just get to where we are compiling. So let's see. So at this point we have fish that we start with, but we need to increment, or we need to initialize our fish by age. So this is going to be fish.group by, I think. I need to look that up. Group by or grouping. Goodness. Actually, this is a good point. I don't need. It's an int to int dictionary, right? It's like this is the age and this is how many we have. Hang on one second. Okay. Yeah, what I don't love about this is it's like, how do you know what these are? I mean, the name here is essentially telling you, but this, I don't know. Not my favorite way of doing it. So, because I think it could be easy for us to confuse these two. Not follow everything from my solution. Take memory, same memory from day 0 to day 1, then from 200 to 201. Yeah, type aliases could help, but that doesn't. The compiler will still allow me to use it, right? let's see what this is. So this would be age is int, and fish count is int. It certainly goes a long way to telling you exactly what this is. So yeah, I like that. Yeah, I think that when we get to this point, it will be an essentially constant memory because we'll only have 8 buckets of integers. And I think that's kind of the point of this is to not do that. Okay, I need to look at array in Swift. And I believe I could have sworn there's a group by here. Group? No. I could use reduce, I suppose. I really thought that there was a grouping. Finding, selecting, transforming, iterating, reordering, splitting, and joining. Okay. If we use reduce, we would take... get out of here. Quit. Oh my goodness. I don't know what that mode is, but occasionally I get into it. It's init on dictionary. Ah, okay. Let's take a look at dash Swift dictionary. Init keys and grouping. Ah, yeah. Grouping values S. Key for value given an element. Yeah, okay. And then where the value is an array of those elements. So it still is going to give me an array, right? I think at that point I would have to map that. Let me open up a playground so I can show you what I mean by that. So let's say I have a fish of 1, 2, 3, 4, 5, 6, or whatever. And then I create a dictionary and I say grouping by. So I say fish by, and this would be grouping by essentially by self, I think. This would give me back, can I not do that? I need to do $0 maybe. Okay, hang on. So this would be an int to an array of int, right? That's essentially the dictionary I'm making. And if I print out D, now I should have the age of 2 has an array of that many. So I need that to be the count of how many fish there are in that one. So if I add another fish in here, then the age 2 has 2 and 2 in it, right? I can't do count here because this is just the integer. So at that point, I could say map values, and I could say $0.count, and that gives me a second dictionary which just has the counts in it. So 2 has 2 fish in it, and everything else has 1. I think that's kind of what I want. Yeah. Okay. Okay. Thanks for that. I was looking for that dictionary in it. So this would be dictionary grouping fish. And at this point, we will have by their age, and then I want to map that or map values to get the count. Let's see if this builds. Build. Okay. At this point, this run simulation is not correct anymore. So, and at this point, the fish string also just needs to print out their counts. But we could potentially print out the counts of each day. So we could say fish by age dot keys dot map age in, and we can sort that. And this would give us the age, and then we could say in that bucket there are how many fish. This would be fish by age for age. And then we could join that by comma, maybe, comma space. Joined separator. Okay. We are now building. Right? Build. No, we're not building. We need a default value. Or 0. No, 0. Okay, lanternfish cannot convert type of int to lanternfish because I think I was mapping to uint8. Let's get rid of that. And yeah, so at this point, our total fish is fish by ages. We need to get all of their... let's just make that a function here. Var fish count. Stream. Okay, so we're going to take our fish by age thing, and we're going to take all of the values and reduce those by starting with 0 and adding plus. And so now we can say sim.fish count. And now we're building. Okay, so we're no longer iterating because we have to kind of figure out what we're going to do there. But in this case now, we're not storing fish anywhere. So lanternfish really could go back to being a struct. And when we say that you are a fish with a given age, and then we say tick, then that's going to tell us what your new age is. Of course, this would then have to be mutating. So we could still use this type. Like not only will it parse the initial state, but we could create the state for each day and then discard it. Because the state for each day is just going to be, that same number of fish. Okay, so let's go back to what we had here. For each day, we need to process all of the fish for a given... so we will say... for given age, right? So we'll take fish by age dot keys, and this will give us the oh goodness gracious, I'm writing Ruby, sorry. For each, this gives me the age in, and then so for this age, I could create a single fish at that age, right? So this would be essentially like a cohort fish. Would be a lanternfish for that age, right? And then I need to say cohort fish dot tick, which if I made that, yeah. So we'll do that. So what does this mean if so for each age, so we definitely need to know like what is the count of those items in the array. because I also need to mutate this dictionary, right? So going over each key, I can mutate the dictionary in this case because I've already gotten the keys, right? This is, let's just give me all the keys, and now I can mutate that. So I can say how many fish at this age are there. So that would be fish by age for age. And then I can get the new age. So we would remove the fish from this bucket. So fish at this age. No, sorry, fish by age for age now becomes 0 because we're taking them all out of this bucket and moving them to the new age. So that would be fish by age for cohort fish dot age, because we've already ticked, so the age would have changed, equals fish by age. Now the thing that we have now is we have a new fish at this point. And so we need to know how many new fish were created this step. And that can just be a simple count. If there's a new fish, then new fish plus equals 1. Okay, and then at the very end of this, now we can say that well, so what we're not accounting for is the fact that the new fish count, like the age. We don't necessarily want the age to be. I want that to keep in this logic here of like, what is the age of a new fish? So if I do that, then I need the cohort new fish and a count. It's a little strange, I guess, but new fish cohort is a single lantern fish. It's a little strange. I could just make it a constant, but value of optional type. Optional int. Well, we know that there are some here. It's a little silly to do this, but okay. 84. Was that the right number from before? No. After 18 days, there was 26 fish, so we have a problem somewhere. We get for each age that we have, we create a new cohort fish at this age. We call tick on it to see what its new age is and if it spawns a new fish. We increment new fish count. And then at the end, that shows us how many fish there are. And I think that I want to add on the total for this age. No, fish count for this day. Okay, so there's 1, 2, 3, 4, 5 is correct here. After day 1, there's still 5, and that was correct. After day 6, there was 6, and I don't think this output shows me the total for each one, but we can do that. So after day 6, let's say, there should be 10 items. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So somewhere along the line here, we are missing a couple. We had 22, and I wonder if we're just missing that last 4, that last step. This is off by 1 error again. Yeah, so here we're saying we only have 1 fish at age 8, and we should have 4. Okay, they're accelerating. Okay, I do need keys.sorted because I need to do these in reverse order, right? Or not in reverse order, in ascending order, because I need to process the zeros first because those are all going to produce. I saved what they're going to produce for outside the loop. Then all of the ones are going to move into the 0 column. If I do them in an arbitrary order, then I'm moving like 4s into 3s, and then I process all the 3s, so some of them are aging twice in one day. So I definitely need these to be sorted in ascending order. So I process the youngest batch first, so I don't actually overlap the buckets before I've processed them. When you've solved this super cool mathematical... Yeah, I definitely know that this is not the most efficient way. I started off thinking that like modeling this as a fish was the right approach. Certainly was not. And now I'm wondering, is this easier with just integers? Okay, so I think at this point, after day 3, there are 7 fish. I think that's correct. Let's go back to our 18 day so we can just test it out. 29, that actually seems not correct. After 18 days, there should be 26 fish. Okay. Okay, so I think the option would be to say that if it's spawned, that we don't want to, like, we can't process this parent again, right? So I've got these buckets, right? So this is 0, this is 1, this is 2, etc., and this is 3. And so let's say the parents who are 0, I'm currently processing this one. The parents who were 0 get put into this bucket, right? And then I move on to this bucket, I move on to this bucket, and I move on to this bucket. Now I'm processing those parents twice. So what I need to do is sort of process the new parents after I've iterated over all of this. Now, the problem is I can't do this in reverse order because then the new ages, everything shifts into the new bucket. Do you want my advice for memory for this part too? I think the memory will be constant with this approach. But sure, go ahead. Right, because at this point we just have like, 9 total buckets of ages with integers in them. Yeah, I honestly I think maybe abstracting this into this fish cohort thing is actually a little bit harder than maybe just dealing with integers, because we have to keep these 2 variables. One of them is a cohort for the new fish, and one is the how many there are at this age, right? And this we see is correct because when we go to when we go to 0, we have 2 fish that are spawning, and then those 2 show up at 8 on the next phase, which is correct. What's not happening is this cohort fish that we just ticked, its age is now 6. And so we 0 out the ones that are at age 0 in this case. And then we add on however many fish are at age 6 now. Because we were saying fish at this age for 6. Sorry, fish at this age for 0 gave me, like, say 2 fish. Say there were 2 fish at this age at age 0. they spawn. So now their ages are those two fishes' ages are now 6. We zero out the ones at age 0, and we set the ones at age 6 to be incremented by 2. This seems correct. Yeah, I don't quite know what's going on here. Let me go back into Xcode and hit my breakpoints. So we're going to wait for day 3. And then we'll go into here. So our age is 0. There's one fish here. So then at that point, if we look at fish by age in the slot 6, there are 2 parents. Was there one before that? There was. There was already a parent in there. Now there's 2. Okay. And in the output we saw earlier, after day 3, there should be 2 fish. And we're expecting there to be 2 parents. Yeah, so this is our problem now. It's kind of like I want to do this iteration, like do all the iteration and now see how many parents are, add the new ones and the new parents at the very end. Like I was trying to resist doing this, like kind of rewriting it, but really what we have is fish by age.keys.sorted for each age in. So we'll have new parents and new children for each day, right? And here we'll take the number of fish at this age, or 0, and we will 0 it out, and then we'll move it down. Fish by age at the new age -1, default 0, plus equals fish at this age. Okay, so before we do that, if the age is 0, then we need to handle this differently. This would be new parents plus equals fish at this age, and new children plus equals fish at this age. Yeah, because we only spawn 1, so this would be like spawn count, maybe. Plus equals fish at this age. Actually, we know that we're never ever going to do the spawn at different ages. And we're iterating over these once. So if the age is 0, then that's how many times we spawn, right? Okay, so then, and we've already zeroed it out at this point. So if the age is 0, we figure out how many we spawn. And at this point now we can say the new parent age, let new parent age is 6, and let new child age is 8, And so now we can say fish by age for new parent age plus equals spawn count, and that needs to be default 0 as well. And same thing for new child age, default 0. Okay. $26. Just so much easier. Yeah, I kind of liked the idea of kind of encapsulating this, but it led us down a path where everything was a little bit, like, a lot harder to deal with. Less code, the better. I agree. If it's more understandable, then I don't necessarily agree. But in this case, you know, I've been going at this for 2 hours. It's way more complicated than it really needed to be. Okay, that works. So now no more lanternfish type. We just have constants for the logic. And we have 26. After 80 days, we have 5,934, which I think was correct. Yes. Okay, and now with our real puzzle input for 256 days, 256. Let's give this a build here and a run over here. And it just ran like immediately. And that's the right answer. Okay, holy moly, that was painful. But I guess, you know, I had to do the encapsulated, you know, object type in order for me to really understand the problem, and then I could kind of switch it. Yeah, that was a lot. It took a lot more time to do that one than I thought it would. But it does show you that exponential growth is kind of insane. So relevant to this, relevant to the world that we live in now. Cool. All right. Well, I'm going to wrap it up, but any last questions or comments or whatever? How much time spent? Way too long. I would lie about it, but all this is recorded and going on YouTube, so. Yeah, I think I started 2 hours ago. Yeah. I don't know why you did a new type. You mean like the lanternfish thing? Part 1 and 2 in 2 hours, yeah. I agree, but there is something called primitive obsession. And it's just, I guess it's my primitive obsession is kind of when you model your everything in your application with ints and bools and strings and dates and things like that. And there are concepts that that are represented in those types as the sort of aggregate of all those primitive types, that sometimes it's hard to see like larger abstractions if you're always dealing with primitives, right? And so if there's a concept that represents something like, I don't know, like a fish or an age or whatever, and sometimes that can, it can be advantageous to try to model your application in actual types and encapsulate the logic and stuff like that. You know, if I were to do this again, you know, I think jumping to that type worked fine for the first part of this, but it led me down the wrong path for the second part. And if I were to do this again and I still want to use the type, I would probably not have the fish represent each individual fish, but maybe just like a fish. You know, maybe we could have like a struct with like that has an age and a count. And then we can also have something like, because these all move together, right? They all move at the same speed. So when if we do age minus equals 1, the entirety of this count moves with it. And that would actually help because, it still wouldn't help because we have to sometimes combine, say the new parents are all age 6, but there are other children that are becoming age 6, and we do have to combine them together. But I do think that there is still value in finding abstractions and not always dealing with primitives. But anyway, this is why we do it, right? Certainly took a lot longer than I thought it should. But anyway, thanks a lot for sticking around. I will probably post, I think, day 3 on YouTube tomorrow, so I'm a few days behind on the YouTube ones, but this will go up in a few days as well. So anyway, I hope everybody has an excellent weekend, and I'll see you again in the next one.